Our atmosphere, a complex mixture of gases, contains a vast and intricate realm of minuscule particles called aerosols. Aerosols can range in size from a few nanometers to several micrometers. And this variability occurs due to a multitude of factors. One of the factors that impacts the size of aerosols is specific geographical location in which they exist. The size also depends on the prevailing weather conditions in different geographical locations. The source of air pollution is another crucial determinant of aerosol size variability. The aerosols emitted from these sources are directly released into the atmosphere and are known as primary aerosols. Anthropogenic emissions of precursor gases and aerosols can undergo physical or chemical transformation to form secondary aerosols. On the other hand, secondary aerosols can also be generated from scratch when gaseous precursors undergo nucleation to form new particles of nanometer sizes. When these particles grow over time and reach a critical size with appropriate hygroscopic properties, they become active cloud condensation nuclei, or CCN. As they grow and accumulate moisture, they evolve into microscopic water droplets that make up clouds, affecting precipitation. The process, known as new particle formation or NPF. Aerosol sizing instruments, such as the Scanning Mobility Particle Sizer or SMPS, play a vital role in detecting NPF events. SMPS operates based on the principle of the mobility of a charged particle in an electric field. The graph plotted using data from Scanning Mobility Particle Sizer exhibits a distinct curved shape, often referred to as the banana plot. The banana plot is a characteristic feature in the graph, showcasing the evolution of particle sizes over time during NPF events. Observations of the formation and growth of new atmospheric aerosol particles have been documented mostly in Europe, China, and the US. However, such observations are scarce in India. A review of total of 25 published studies in India on NPF provided valuable insights into various aspects of NPF events, including the factors that influence and regulate NPF. These studies were conducted in different geographical locations across India, encompassing urban and rural settings. The findings from these studies shed light on the complex interplay between local sources, meteorological conditions, and air quality in shaping NPF events. For example, studies show that new particle formation took place during periods of heightened solar radiation and less in the absence of sunlight when the intensity of solar energy is its least. Another study showed NPF occurrence to be higher in urban areas compared to rural and mountain background sites. In a significant breakthrough, a study conducted in India established likelihood of newly formed particles surviving and growing to sizes that make them cloud condensation nuclei, which is typically above 50 to 100 nanometers. In India, most studies have focused on size distribution of aerosols, but underlying chemistry is still unknown. Also, the precise contribution of newly formed particles to cloud condensation nuclei production and their potential for cloud formation remains uncertain. Further investigation is essential to unravel the intricacies of this process. Another aspect of new particle formation that requires further assessment is the relative contribution of volatile organic compounds to new particle formation. And most importantly, the role of NPF in haze formation requires further research. This investigation is critical for unraveling the intricate mechanisms behind the creation and persistence of atmospheric haze. In order to unravel the unexplored realm of new particle formation, it is crucial to foster collaboration and commitment among researchers, institutions, and stakeholders. As we venture into this uncharted territory, unified efforts will lead to groundbreaking discoveries, illuminating new paths in atmospheric science. This shall enable us to address the intricate interactions between aerosols, clouds, and the Earth's climate system, which is still to be fully comprehended and plays a vital role in shaping our understanding of climate change.